what we have here is a robot platform. There's no specific task or goal for this robot, unlike the other ones you've seen on my channel. It's just a basic building blocks with some additional toys to test sensors, microcontrollers, embedded computers, software, other kinds of gizmos and gadgets. This top level isn't even populated. I just have the Velcro strips on here, as well as the bottom. It's attached with lock nuts in the bottom and wing nuts in the top, just to make it thumb accessible to remove the platform. And I'll go ahead and take this off and put it on the side when I show you everything on the bottom level. This is a mix of the bare necessities for a robot with a bunch of other unnecessary gizmos and gadgets that we'll go through real quick. 3D printed claw on the front with a servo. This is not coated up yet, so there's a lot of work to be done with that. Ping ultrasonic sensor on a servo. A little laser here that's attached to a very basic transistor circuit, so it's got enough current from the power supply in order to be very, very bright and have a long beam. We've got 2 infrared sensors on each side, just in case the ping sensor isn't enough and it's turning into objects that will be sensed. We also have an Arduino Uno, a Bluetooth shield, it's a Bluetooth serial communication. I can't show you because my Bluetooth device is the tablet that this is, the video is being recorded on, and an Arduino official revision 3 motor shield, which was gifted to me. It's got a lot of cool features on it. It's really nice to use that. We also have a Raspberry Pi with Wi-Fi connected to, well, you'll see this ribbon cable is connected to the T-cobbler, so the Raspberry Pi, you can just disconnect this cable and use that Raspberry Pi in a different project. Good to go. So to show you the breadboard setup, what we'll do is tilt her this way. It's going to be hard to see everything, but there's a little red board down here, which is a logic level converter, because everything's basically 5 volts except for the Raspberry Pi, which is 3.3 volts. So the serial communication link between the Arduino and the Raspberry Pi has to go through the logic level converter, which is 2 channels, one for receive and one for transmit. So we're going to take the 5 volt serial from the Arduino and convert it to 3.3 volts in Raspberry Pi and vice versa. So that works. The other 2 channels on this chip are going to be used as kind of a little tricky, clever hack for these 2 infrared sensors. They operate off of 5 volts. They will work on 3 volts. The main problem is the actual distance of a detected object. The distance this way that it detects on 3.3 volts is lower. So I'm powering it and running it off 5 volts, and then I'm taking the sense pin and one on each channel to the logic level converter, converting it down to 3.3 volts to the GPIO for the Raspberry Pi to be able to read those sensors. This is the T-cobbler breakout, and hidden in here, which you can't see, is the sound impact sensor from Parallax I had laying around from a long time ago. And that allows the laser to kind of operate like the clap system. So go ahead and keep an eye on there. And that's just kind of analog. There's also a software command to turn the laser on and off, but just to show you, you don't need to have too much digital logic to have that operate. Moving back to the breadboard, up here is the mess of power cables. So how the whole power system works, which we'll talk about now. This is a step-down converter that's adjustable, potentiometer based. The battery pack's 14.8 volts, which can be 16 volts when charged. So that's going to go ahead and go through the converter to make sure that what's coming out is 12 volts. The motors need 12 volts, as well as any other future devices like the Kinect and things like that. So one side of the power rail is 12 volt power. The other side of the power rail on the breadboard is 5 volt power, and that's stepped down over by a UBEC here, which will take a very wide range input voltage. I think it's 6 or 7 to 24 volts, and give you out 5 volts clean, filtered at 3 amps, which is enough to run everything on 5 volts that we need here. And this 10 pack is a lithium-ion 18650 for cells with a protection circuitry, 2.2 amp hours or 2,200 milliamp hours, whichever way you want to look at it. Those are pretty cool. And on the back side, we have the power bus systems readouts. This is your current, the amperage being used from the battery pack in the circuit, and this is the voltage from the battery pack as well. So that just gives us some ways to monitor real time, the system power standby. So now we'll take a look at the motors and the This is a very basic 12-volt motor system that was purchased off eBay. It came shipped in from China. They're just little tiny gear motors with some wheels and hubs and mounting hardware. Very, very basic. I have not tested the stalled current of this thing yet, of these motors. The little caster wheel at the bottom is just a simple caster. They got these little shiny rims on them, remind me of some kind of RC car thing or something like that. But they do just fine for this robot, moving them around and getting the locomotion down indoors. That's the basic overview, and again, everything's not coded, but I do have a laptop off screen that's got a connection to the robot, so I'll do some basic features. This will just read the ping sensor. So once you're actually, see, he's looking left, it's reporting back the distances that it's measuring so that the system that you're using will be able to get that information. And here's the command. See, the laser's on now for the laser, so that's controllable. And we'll just do some turns here. It's very, very basic. You'll kind of see some current change if you can catch it there. Looks like it spikes about 360 milliamps. And you can combine commands like that. See how the laser's on? Because the noise was high enough. So it's got some features to it, some good range of motion here. What I'll do is I'll try to, there's not much room on this table here, so this might be a disaster. But we'll go ahead and give it a shot at going a little forward for a little bit and then stopping quickly. Yeah, that wasn't too bad at all. Looks like 430 milliamps was the peak that I could see. Look at that laser on the box there. See that dot? So it's a very basic, and this is just serial communication right now. This is the same functionality you would have if you were connected via the Bluetooth.